I'm solutions architect at CloudMate, and currently I'm working mostly with automotive industry, but also with social media. And one of my projects is regarding social and how we working with data. Uh, how many of you worked previously with Hadoop, or at least know what Hadoop is? Okay, perfect. uh, I will start with typical database, what they is, and then I will go back to what Kudu is and how they work together. In fact, all typical databases starts from four different type of layers. First one is protocol layer, which is SQL. Then we need query processor, how to convert from SQL to query data which is on disks, then storage engine, and some additional shaders, buffer pools, etc. In fact, what Kudu is working on storage level and this SOLOS layer. It's not a database like MySQL or different. Kudu give you also an ability to work directly with Impala, and Impala is Hadoop based from Cloudera. That's why Cloudera currently Kudu is based on Cloudera. At least it has hard dependencies. You could work directly with storage engine. You could ask for some records. You could ask for scans. It's low level how to work with Kudu, but most of the time you want just DBC connectors or DBC connectors, at least SQL queries. That's why you should use Impala, at least for now. How everything goes previously, before Kudu. Time to time you have some incoming data. It could be from messaging system, it could be from ETL processes, it also could be some updates which you received from different stages. Then you save data if it's Hadoop, mostly in HBase. And then time to time you run a scheduled job to create the Parquet files, which are really great for a lot of different SQL queries, and store these Parquet files somewhere on HDFS. Use Impala or use Hive or use some additional tools to work with data directly and with SQL. There's one big issue here, is that when you need to store Parquet files, you need to store them in some particular place. And in those places, you also need to not only generate where it will be, but also generate file formats, generate storage locations, and grant for different users ability to work with different subsets of data. In fact, it's hard. Also, it's hard to maintain when your team of developers is not 1, 2, 3, 10. When you have 50 developers, it's hard to ask everyone, please use our naming convention policy, please store data where we need it, and maintain all of scheduler jobs which you implemented previously. But, okay, this is Hadoop, but could we just scale our SQL databases and this will be okay? In fact, scaling MySQL and Postgres is really painful. If you try it at least once, you will never try it again. You could work with Hive plus Parquet, but as I mentioned previously, it's still painful. You need to keep in mind a lot of different issues. On one conference, I heard from one of guys that I had a database with something like 1 terabyte of data, and I want to scale it and work with it. What I could do with open source world? Answer from one of speakers was, first of all, you could kill yourself, and it will erase your issues. Second one, okay, you could use Oracle, but you need to sell your kidneys. That's all. You don't have any abilities to work with SQL as you prefer and work with this data in the manner what you prefer. But, okay, I start talking from Kudu. Is Kudu so painful as working with different? I will return to these questions at the end. First of all, where Kudu is. Kudu is in the middle between working with HDFS for big analysis for the whole data set which you have, and HBase, where you have an ability to get your result but by ID in milliseconds, or create some subscans for different subsets also in milliseconds. Kudu is between. It gives you an ability to scan big amount of data with really good performance. I will mention performance on my project with something like 100 gigabytes of data in SQL, and show you how it's work and what is performance speed. But first of all, as I mentioned, Cloudera now covering the Kudu itself, Kudu project. They implement a lot of different abilities how to work with Kudu, and they give them money, at least. So I need to cover one use case where Kudu is really helpful. They worked with Xiaomi previously, and in Xiaomi, it was a straightforward architecture, which I think everyone using now. They have Spark, then they store in data into HDFS, and then use Impala to query this data. It's really helpful. You could find in enterprise systems a lot of similar architectures, but what they changed? They integrate Kudu as middle layer for OLAP queries, and they use Storm just to push data into database directly. Yes, of course, they use Impala because they have hard dependency for SQL syntaxes. And what is the performance? There's no silver bullet at all. So on inserts, they have reducing in speed from 23 million records per second up to 2.8. So 10 times reducing in speed. It's not critical for Xiaomi, but it could be critical for your issues. What they get as a result, they also get the very speed up in very big speed up in returning queries in result. Latency reduced from, on query 6, it's shown, from 16 seconds to 1 second. So you need to define, do you need fast inserts or you need just good latency in your queries? How Kudu works? In fact, Kudu work like most of storages. You have one master, and then you have replicas. Replicas could be on different server, or it could be on one of your server. This gives an ability to at least stop one of your instances, and without losing an ability to work with database directly. It also gives you an ability to work with replicas in something like read and speed up your process at all. Each tablet is a separated folder, just folder, and each master or slave give you an ability to understand whether you have something now in your database or not. How could you relate it to CAP theorem, and is it consistency, partition tolerant, availability? In fact, we have here our replicas, but it's still consistency and partition tolerance. Kudu grant you an ability to understand that if you have at least one record inside your system, you will receive it on each node in each tablet. It also gives you an ability to scale a lot, scale horizontally, but unfortunately they don't have an ability to scale vertically. What does it mean? If I have, for example, 10 hard drive disks, and I want just to add one more, Kudu will not support this. So you will not have an ability to add one more disk and everything will work. Unfortunately, with Kudu it will not work. I asked not once in their Slack chat, but result is we're working on that, unfortunately. But they give you an ability to work with SSD disks without losing any performance. So if you're working, for example, with HBase or HDFS, they don't have an ability to speed up dramatically if you're using SSD instead of sequential hard drive disks. Kudu has this ability inside their core system. But okay, it's Kudu and SAP, and let's start with partitioning. Partitioning is inside Kudu, As similar as all SQL storages, you have an ability to create range or hash partitioning. It's normal for everyone, but they also implement multi-level partitioning, which is hash range and hash hash. With range partitioning, it's very easy. So you just scale, for example, by date and store data from 2014 to 2015 in one tablet, another part in another tablet, and so on. But in this case, you could have some bottlenecks. It could be a situation that in 2014 you don't have any data, then in 2015 you have some data, and in 2016 you have a lot of data. How to cover that? In fact, they have hash partitioning. With hash partitioning, then they provide you something like scaling, but with ability to store data linearly between all of tablets with some hash algorithm. But unfortunately, it's not working if you still have an issue with searching of these big tablets inside. It could be situations that one tablet has information about, I don't know, region of users, and then you want to count something from region of users. And this region could be, for example, China and, I don't know, United States. In this case, in China, you have more profiles and more users than in United States. How to cover that? You could create a range hash partitioning and save data, for example, by hash from one side for China, and then save also on another side for, I don't know, year or by ages or by something like that. This grants you really good ability to work with your data in different buckets at the same time and receive your results dramatically faster than it was previously. But okay, I still have the range, and I really don't want to have it in production system. I could move to hash hash, but with hash hash we need to keep in mind that everything what we'll have is hashing, and we don't know their hash algorithm, so we need somehow to work with this data. And if something will goes wrong, we will need to figure out where it goes wrong. I will say a little bit more about errors a little bit later. But first of all, what they also give you an ability. First of all, they grant you an ability to store your data in the not only fastest way, but also in the more efficient way. They provide an ability to zip or compress your data directly as a rows, and this increases your speed. This reduces your speed, but increase your performance dramatically. On this, volume dramatically. Second, they give you an ability to use encoding. Encoding gives you 5 different stages. First one is plain, where you just save your data directly. Second one is bit shift. So if we have 111 and in second row we have 112, they will just save the difference between these two cells, and that's all. This reduces the space on one of our projects from hundreds of gigabytes to tens of gigabytes. Because data don't change dramatically, for example, for timestamps. You don't need to save big integers. You don't need to save if it's strings and this is URLs. You don't need to save the whole URL itself. Third one is run length. It's very good for repeating values. So it's not storing them at all. It's just a pointer that this information is similar to previous one. That's all. And the fourth one is dictionary. So you create, it's like an enum in Java, and that's all. And the last one is prefix. So if we have some prefix in different regions, we could just use this prefix and not storing it at all in our database. It's very also useful. I will show the performance on one small server with 50 gigabytes of CSV data. I will return back, but it's only 50 gigabytes of CSV with hard drive disks. Hard drive disk just for test, because now I migrated to SSDs, and range hash partitioning without any encoding. Performance for last 10,000 requests from data science team, all requests are less than 500 seconds, 500 milliseconds. What does it mean? It means that any request which data science team runs for last period of 10 minutes, they return almost in second. But I really understand that it's impossible. Okay, let's see the distribution across all the time. And in fact, here you could see that some of requests are really bad because it's 11 minutes, it's 6 minutes. Yeah, time to time I found that Kudu is not working really great. It could be due to some restrictions in SQL code. It could be due to some restrictions in what we wrote as developers or data scientists. And it also could be due to compaction or similar problems. But previously I mentioned that Kudu, I had the data set for 50 gigabytes. 50 gigabytes is just CSV. Previously we worked with MySQL. And in MySQL, the size of the database was 100 gigabytes. Why? In fact, we're using partitioning itself, and with partitioning we're using indexes. And index for each partitioning provide you 50 gigabyte more storage. So, and you need to pay for it. Paying for 50 gigabytes were not useful for us, for at least for that moment. That's why we figure out moving to Kudu, but is Kudu better? In fact, with Kudu, the same data set is only 27 gigabytes. And in meta information, with all the indexes, with everything inside, it stores only 2 megabytes of data. So the whole metadata is 2 megabytes instead of 50 gigabytes in MySQL. I think it's good. But where to use and where not to use Kudu itself. It's very good when you're using time series database, or at least when you try to work with time series data. It's very good for online reporting like charts, etc. Because it provides you results in seconds. It could be a really rare case when you receive some results in 10 of seconds or 1,000 of seconds. And it's very good for machine data analytics. It's not machine learning, it's just analytic of data which you stored for different machines. That's all. Where not to use. In fact, it's not good to use, and I do not recommend you to use Kudu with normalized databases. If you have a lot of connections, Kudu will not support that. If you need fast random access, just use HBase and it's great. When you need fast sequential scans, yeah, directly, you still need something like HBase for sequential scans. If you want to avoid Hadoop and Spark, unfortunately, Kudu dependent on Hadoop stack, so you don't have an ability to choose something else. And when you want to create strategic planning, so for strategic planning, almost all of the time you need the whole data set. In this case, just work with Spark or ORC file formats, and that's all. But what is about pros and cons? I will start with pros, like all presentations. It's scalable storage horizontally, fast alter table, so you could add as many columns as you want. It could be not a rare situation when someone from product manager team came to you and say, okay, we need one more column in this small table. In fact, it's not small, but we still need this column. And you run the alter table on production server and everything fails. Or at least it's not fail, but it took, I don't know, hours or maybe days when it's processing. And anyone don't have an ability to work with this data at the same time. They use compression support. So you could use LZ4, you could use Snappy, you could use Gzip, and reduce your volumes dramatically. It has, what they say, pros. For me, it's cons, but at least built-in integration with Impala. So with Impala, you could just query your data directly from Kudu with no issues, they say. And they also have built-in upsert. But, okay, this is pros. Everything is great on any conferences where you will see someone from Cloudera. They will tell you, and stop on this. I will tell you more about cons. First of all, they don't have any foreign keys at all. So you don't have an ability to connect your different tables. That's it. Second one, they don't have auto increments. And if you had a chance today take a look on Spanner presentation, they also don't have auto increments. In fact, it's very hard to create something like that in distributed systems at all. Third one, errors in JDBC are not readable at all. I will give you an example in 2 slides. First one, they don't have an ability to run subqueries on updates. And they will not give you a chance to just write something above that. So if you have somewhere in your code update table set f1 as a select from different table, it will not work. You need to rewrite it somehow. They do not support transactions. They do not support functions and procedures. So you will need to rewrite this inside your code. Not good. Next one is limit in order by. All of us know that we write order by statement and then limit 1, 2, 3 to create at least a paginators. But with Kudu it will not work. You need to write it somewhere by your hands inside your code. Not good. Disks can be scaled. What does it mean? I mentioned previously that if you just add one more disk, it will be empty forever. You just, how they told me in their Slack channel, it's very easy. You just need to add one more instance in AWS. Yeah, it's good, but somehow and someone need to pay for that. I am not sure that I want one additional instance. I need just storage. They have some other limitations, and the main limitation, as for me, is that they strictly dependent on Cloudera Impala itself. But I mentioned that errors in JDBC are not readable. Errors are everywhere. We all are developers, and we all understand that we can't write a really good code without some issues, without some bugs. But we should provide an ability for everyone to understand what is inside data and how to at least understand what's going on. Small history from my life and working with Kudu. On that server, we had an issue that we received low disk space error, and it was while Kudu start compaction process. So disk space was something near to 0 kilobytes, and Kudu stopped working. Then we add some disk space, restart, everything start working, everything is great, but not at all. So if we try to understand why some of tablets not starting, there were no errors. One error was connection refused. Okay, but connection refused, what it is? I start searching in log and find not an error, a warning that corruption, flash to disk failed, bad magic. Damn, bad magic, what it is? How to work with this data. I wrote to their channels, they told me that, okay, it could be due to low disk space, you need to somehow manually delete some folders, then restore these folders, then send some meta files to their team, they will somehow fix it, and then return it back to you. You need then deploy these files to your server, and everything works correctly. Okay, let's believe in that. In some time, I found the next issue. Next issue was on some SQL statements. It was rare for us, but it still was bad magic. I still searching for data and trying to understand how to work with it, how to work with data, how get understanding of what's going on here. Bad magic, it's not a reason. And in fact, it was an issue that a lot of different columns in some tables not working at all. So what they done when they changed the file, they just remove an ability for this tablet to return back to you some columns. And if you need these columns, it's a bad magic for them. Okay, I spent after that something like a week of understanding what's going on here and how what is bad magic inside is, and found that they created a distributed system, not a system for one machine. What does it mean? It means that if leader fails due to some reasons, at the end of each file they wrote magic numbers, and they checking their system checking for these magic numbers for all of files. And if they found that one of files on different tablet doesn't have this magic number, they stop working with this server at all and trying to get data from leader. In my case, it was leader. So what they implemented inside code, they stopped this leader at all and move leader role to another tablet for follower. In my case, there were no followers, that's why it was bad for me. But when they have this follower, what start going on? First of all, they stop all connections with leader for all other machines. This process took a lot of time if you have not X servers, but if you have dozens of them. I checked how much time it take when I working with 100 AWS servers, and time of understanding that leader is now corrupted took up to 3 hours. So it's not quite good. I wrote to them, they say, okay, they will try to understand and try to work with that. But at least they understand that data could be corrupted. They should work somehow with that data. The next stage, what they're doing, they reassign leader role to another follower and start the process from the scratch. Yeah, you could achieve some timeout errors when the process is going on, and you need somehow to start replication of your data. Kudu will give this to you. Unfortunately, they also have one additional issue, is that if you will try to do this system on production, you will need to wait some time. So they used raft consensus, but it still took, for example, something like 10 seconds, and in this 10-second timeout, no transactions going on. I'm not sure that everyone should use Kudu, at least now, in production systems. I hope they will resolve all of their issues which they have now in Q1, Q2. It's very good when you just work in-house and you want to understand your data. It's very good when you want to create some dashboards for some of your team. If you want to use it in productions, I suggest you just to wait at least for Q2 2018 and then start using it. Cloudera working a lot on Kudu. I saw this in their reports. I saw it in the Jira tickets and how they work with it. So they're spending a lot of resources to this project, but you need to wait. Also, I need to mention that there is one additional tool in Apache which is similar, but it's still very painful to use. So if you want to have some SQL syntaxes over different databases, different structure right now, with production ready, just try to use Apache drill, but you will still have a lot of issues inside, and you will need somehow to work with them. Questions? Only one? Yes?
It seems to me that Google Cloud Spanner provides a similar functionality, and I can't see a point of why we should use Kudu. So the question is, could you provide a brief comparison performance-wise, price-wise, and maturity-wise? What should I use when?
So in fact, Spanner is only cloud platform, which which not allow you to deploy something in your cloud or deploy at least in AWS. It gives you just an ability to work with Google Cloud as it is. The second one, with Kudu, you just need to pay for the instance. In Spanner, you need to pay for instance, pay for traffic, pay for disks, and in addition, you pay for Spanner itself. So in price comparison, it's better to use Kudu.
Thank you for your speech. I have a question regarding can Kudu be deployed to multiple data centers?
Yeah, it could be deployed to multiple data centers, and also they have an ability not only to deploy it, but also to mention that this tablet should be on in one data center, another tablet should be in another data center. This gives you an ability, for example, for GDPR restrictions, which will be in the May of 2018. So you could just say, okay, all users from European region should be in this data center inside the European region. All users from China should be in China.
About timing, on speech about Spanner was mentioned some clock cases and leader election, and how Kudu resolve these problems.
So in Kudu, they still don't have a good understanding how to work with it. They use the same approach as Google Spanner, but unfortunately, they are not Google. They don't have atomic clocks in each data center, so it's up to you to decide how to work with that. They have some plugins which allow you to work, but only if you have these services in your data center, and your data center supports that. Thank you for attention.